Today we're going to talk about 6.4, which are 3 specific types of parallelograms. So these shapes are going to have all the characteristics that a parallelogram has, but then they're going to have a couple of their own special, unique characteristics that makes them their own shape. So for example, a rhombus is a parallelogram with 4 congruent sides. So again, it is a parallelogram with 4 congruent sides. A rectangle is a parallelogram with 4 right angles. And then a square is kind of a combination of the two. A square is a parallelogram with 4 congruent sides and 4 right angles. Now, of course, these are going to all have their own individual theorems. So if a parallelogram is a rhombus, so basically given a rhombus, then the diagonals are perpendicular. So here's your rhombus. When you draw your diagonals, the diagonals create a right angle where they meet. Okay? Again, another theorem here is if a parallelogram is a rhombus, so given a rhombus, then each diagonal bisects a pair of opposite angles. So in this picture, okay, this is a rhombus. In this picture, this diagonal makes angles 1 and 2 and 5 and 6 congruent. It makes angles 3 and 4 and 7 and 8 congruent. This diagonal makes 3 and 4, 7 and 8 congruent. All right? So in our first example, it is asking for the measurement of the numbered angle in rhombus ABCD. Okay, as I take a look at this, the first place I can start, without a doubt, if it's a rhombus, then we know that angle 1 is 90 degrees. Okay, now a rhombus is a parallelogram, which means that this angle and this angle, the whole thing, so angle ABC and angle CDA, they're congruent because opposite angles in a parallelogram are congruent, and a rhombus is a parallelogram, which tells me if this angle is 58, then angle 3 is also 58. And if you recall, diagonals bisect the angle. So if angle 3 is 58 degrees, then angle 2 is also 58 degrees. Okay. Now, if I take a look at this triangle right here, all right, it's triangle angle sum theorem. There are 180 degrees in a triangle. This angle is 90. This angle is 58. So 90 plus 58 plus, we'll call that x, angle 4x, has to equal 180. Okay, when I add these all up and subtract to find x equals 32. So this angle measurement right here is 32 because I did 90 plus 58, subtracted that from 180, and was left with 32 degrees. Okay. On your next example, we want to find the measure, same thing, of the numbered angles. So in this case, again, they're telling you it's a rhombus, but all rhombuses are parallelograms, so it has all the characteristics of a parallelogram. So in this case, we know that this diagonal is bisecting these two angles. So that makes this triangle an isosceles triangle, which means that angles 1 and angles 3 are the exact same measurement. To figure that out, take 180 and remove from it 104, which gives you 76 degrees to divide evenly amongst angles 1 and angles 3. So 76 divided by 2 tells me that each one of these angles is 38 degrees. But again, it's a rhombus, and a rhombus, the diagonals bisect the angles, so angles 2 and angles 4 must also be 38 degrees. All right. Shifting gears here to talk a little bit about rectangles. If a parallelogram is a rectangle, then the diagonals are congruent. Okay, so when you draw your diagonals in a rectangle, or if they're given to you, AC and BD are the exact same length. So, in your first example pertaining to rectangles, it says the rectangle RSBF SF, which is this right here, is 2x plus 15, and RB is 5x minus 12. Well, those are the lengths of the two diagonals. So very simple. We need to set them equal to each other because the theorem we just discussed said that diagonals in a rectangle are congruent. So their measurements are equal. Now, to be consistent with what I've taught in the past, we're going to get the variable to the left. So we're going to subtract 5x from both sides. Negative 3x plus 15 is equal to negative 12. Minus 15 from both sides, negative 3x is equal to negative 27. Divide both sides by negative 3. And x is 9. But they didn't ask for x, they asked for the length of SF and RB. So to find SF, for example, we're going to take 2 times 9 and add that to 15, which tells me that SF is 33. And the same thing for RB. Now we should get the same value. We should get 33 because they're equal lengths. But just to make sure, 5 times 9 minus 12 does in fact give me 33. Okay? Example 3a, very similar to the one we just did. Again, in this case, LN, which is this diagonal right here, is 4x minus 17. And MO, which is right here, is 2x plus 13. So again, they're giving you the lengths of the diagonals, so we know their measurements are equal. So 2x plus 13 is equal to 4x, we'll write it the way you probably are going to write it. 4x minus 17 is equal to 2x plus 13. So get the variable to the left, we're going to subtract 2x from both sides. Add 17 to both sides. 2x equals 30, which gives me x to be 15. If x is 15, they're asking for the length of ln. So 4 times 15 minus 17. When I do that, that comes out to be 43. And MO is equal to 2 times 15 plus 13, which is also 43. And again, they should be the same amount because the diagonals are equal. And then finally, as we take a look at this last question, it's asking what type of triangle is triangle PMN? Okay, well, we know that the diagonals in a rectangle are congruent, but don't forget it's also a parallelogram. So parallelograms diagonals bisect each other. That's how I know that this piece and this piece are the same, and this piece and this piece are the same, but all four pieces are congruent because the diagonals in a rectangle are the same length, but I know they bisect each other because a rectangle is also a parallelogram. So that creates a isosceles triangle. All right, that's it for the notes. You should have a homework assignment posted on Google Classroom for 6.4. So if you have any questions, I will be back to answer them on Monday. Have a good day. Bye.